This 5th of May, 5-5, the perfect day to talk about 5 secret formulas that changed how the world eats. They're called the mother sauces: bechamel, velouté, espagnole, tomate, and hollandaise. But here's the question no one asks. What if these recipes aren't just cooking? What if they're mathematical proofs written in butter and broth? Today, we're not just making sauces. We're decoding the ratios, the reaction times, and the chemistry that makes your brain say delicious. And along the way, we'll ask, in an age of avocado crema and spicy aioli, do these 200-year-old formulas even matter anymore? Let's find out. 5 sauces. 1 language, math, bechamel, velouté, espagnole, tomate, and hollandaise. Let's cook with numbers. The story begins in 19th century France. Chef Marie-Antoine Carême, the architect of haute cuisine, noticed something brilliant. Hundreds of sauces in French kitchens could be traced back to just 4 foundations. A map of flavor, simple roots, endless branches. Carême gave chefs a system to build on. Decades later, the legendary Auguste Escoffier refined the system. He dropped allemande as a daughter and added hollandaise and sauce tomate. Suddenly, there were 5 mother sauces. But here's why chefs still revere this system. Escoffier didn't just list recipes. He created a mathematical taxonomy, a logical framework where hundreds of daughter sauces could be generated from 5 base formulas. It was the periodic table of French cooking: bechamel, the white foundation; velouté, the velvet; espagnole, the brown; tomate, the red; hollandaise, the emulsion. From 4 to 5, from tradition to theory. Now, the math. First up, bechamel, a white sauce made from milk and a white roux. Here's the math. Roux to liquid is typically a 1-to-10 ratio. For every 1 part roux, you need 10 parts milk to coat the back of a spoon. Change that ratio and you change physics. Less milk yields a paste, more becomes a light soup. This is ratio and proportion, the most fundamental math in cooking. Velouté means velvet, structurally identical to bechamel. Same 1-to-10 roux ratio, but you swap milk for a clear stock. 1 substitution, an entirely new mother sauce. Change the input, change the output. Mathematical substitution in action. Espagnole, or brown sauce, is where math gets aggressive. The roux is cooked darker, 7 to 15 minutes instead of 3 to 5. Then add browned bones, mirepoix, and tomato for depth. A light roux thickens more than a dark roux. Time is the variable, a function of time over heat, a calculus of caramelization. Sauce tomate feels familiar, but French tradition is unique. Escoffier starts with salted pork, mirepoix, and yes, roux. Then tomatoes, stock, and a sachet of herbs. Reduce slowly as water evaporates and flavors concentrate. The final sauce is roughly 1/3 the starting volume. Simple exponential concentration. Finally, hollandaise. This one breaks all the rules. No roux at all. The thickener is egg yolk and the liquid is butter. 5 parts butter to 1 part yolk by weight. Hollandaise is an emulsion, forcing fat and water to mix through mechanical energy. Millions of butterfat droplets suspend in a continuous water phase. Egg yolk is the mediator. It is colloidal mathematics on your stove. 5 formulas, 5 outcomes. But why do these sauces taste good? That is where chemistry and biology meet. Start with Maillard reactions. When you brown that roux for espagnole, amino acids meet reducing sugars. You create hundreds of new flavor compounds: pyrazines, furans, thiazoles. Time and temperature are the variables. Then there is umami, the 5th taste, discovered by Kikunai Ikeda. Umami is the taste of glutamates, abundant in aged cheeses, tomatoes, and browned meats. When you simmer a stock or reduce a sauce tomate, you concentrate natural glutamates. Those glutamates trigger receptors that signal protein-rich and nourishing. And acid? That is for balance. Lemon juice or vinegar cuts through fat, resetting your palate. This is sensory contrast, the secret to why a heavy dish still feels light. Mother sauces hit every evolutionary pleasure center we have. Fat satisfies. Umami signals nourishment. Acid balances. Maillard adds complexity. It is not delicious by accident. It is delicious by biological optimization. Math, chemistry, biology, aligned on your plate. So, what about today? The debate begins. So if these sauces are elegant and irresistible, why debate their relevance? Critics point to nouvelle cuisine, lighter, fresher sauces not bound by butter and roux. Other cultures have their own mother systems, master stocks, mollets, curry bases. In 2025, some chefs call the French canon outdated. Modernist cuisine uses thickeners that follow different mathematical rules. Plant-based diets push innovation, vegan bechamel, umami-rich miso infusions. But culinary schools still teach the mother sauces because they teach principles, not recipes. Bechamel teaches ratio. Velouté teaches substitution. Espagnole teaches time. Hollandaise teaches emulsion physics. These are transferable mathematical models that work with any ingredients. Make a vegan bechamel using soy milk and a nut-based roux. The formula is the same. To break the rules, first understand them. The mother sauces remain the clearest proof. So on this 5th of May, we celebrate 5 recipes that changed cooking forever. They are history, they are chemistry, they are applied mathematics. Why does food taste good? Because someone did the math. From a 1-to-10 roux ratio to the physics of an emulsion. Remember, math is delicious and more importantly, math isn't magic. It's everywhere.